Dairy farming is among the most energy-intensive forms of agriculture, with around 20 to 30% of the energy dedicated to the milk cooling process. The best practices outlined in this video are proven to reduce energy costs for the milk cooling process and decrease the environmental footprint of dairy farms. Energy-efficient dairy production lowers costs for producers and helps to ensure a sustainable future for dairy farmers. Achieving these savings may involve reconfiguring the milk cooling system or adding equipment. In this video, we'll discuss 4 technologies that can help dairy farms conserve energy and reduce costs. These systems can pay for themselves in energy savings in 3 to 9 years, depending on the equipment. Milk pre-cooler. In an energy-efficient milk cooling system, a milk pre-cooler, typically a plate cooler, uses groundwater to cool the milk. Plate coolers consist of a series of stainless steel plates installed in the milk line between the receiving tank and the milk storage tank. Cold water passing through the plate cooler on one side of the plates absorbs heat from milk passing on the opposite side of the plates. Milk pre-coolers greatly reduce the amount of energy used by the refrigeration system to cool the milk to the targeted temperature. An appropriately sized milk pre-cooler can reduce energy use for milk cooling by up to 60% and extend the life of the refrigeration system. In addition, the warm water from the plate cooler can be used for washdown and other purposes based on local ordinances. Variable frequency drive controlled milk transfer pump. After a milk pre-cooler is installed, the milk cooling system can be further optimized by using a variable frequency drive, or VFD, to control the milk transfer pump motor. A VFD automatically adjusts the speed of the milk transfer pump motor in order to maintain a steady flow of milk to the pre-cooler. A milk transfer pump VFD is only recommended if the farm uses a milk pre-cooler. A VFD-controlled milk transfer pump can provide additional energy savings of up to 15% for the milk cooling system. Scroll compressor. Replacing conventional refrigeration systems that use a reciprocating compressor with one that uses a high-efficiency scroll compressor will offer significant energy savings. Scroll compressors have fewer moving parts and can be controlled by variable control technologies which enable the compressor output to match the cooling requirements. Refrigeration heat recovery. The milk cooling system typically uses one or more refrigeration units to remove heat from the milk and expel waste heat to the atmosphere. This process can be improved by utilizing a refrigeration heat recovery system that captures waste heat generated by the refrigeration unit and uses it to preheat water for cleaning and sanitizing purposes. The refrigeration heat recovery system can reduce energy used to heat water by 20 to 60%. On a dairy farm, it's all about the bottom line, and fortunately, with technologies like milk pre-coolers, variable frequency drives on transfer pumps, scroll compressors, and heat recovery equipment, combined with best practices, farmers can significantly reduce their energy usage and utility costs. For more information on dairy energy efficiency, please visit nyserta.ny.gov/agbestpractices.